Good morning, everyone. Today we are going to study electric field intensity due to an electric dipole at an axial point. I repeat, electric field intensity due to an electric dipole at an axial point. Now, before going through the derivation, let us first revise what is an electric dipole. An electric dipole is an arrangement of two equal and opposite charges separated by some distance. In this diagram, if we see, there are two charges of equal magnitude Q and Q, but their nature are different. That is, if one is positive charge, the other is negative charge, and they are separated by some distance twice A. Now this particular distance that we see between the two charges is called the length of the dipole, and O is its center, that is O is the center of the dipole. And in case of dipole, we always consider this distance as twice A, and here we have half of the distance as A and other half of the distance as A, and hence the total is twice A. Now, associated with electric dipole, there is another vector quantity which is known as electric dipole moment, and its expression is P equals to Q into twice A. That is, electric dipole moment is a vector quantity whose magnitude is equal to either the magnitude of either of the charges of the electric dipole, that is Q, into twice A, that is the distance between the two charges. So this is an expression for electric dipole moment. And a very important thing, the direction, as it is a vector quantity, the direction of electric dipole moment is always from the negative charge to the positive charge. That is, in this particular setup, it is directed towards the right hand side. This is the direction of electric dipole moment in this particular case. Say for example, if we interchange these charges, that is, if this is a positive charge and this is a negative charge, say for example, then the direction of electric dipole moment is also going to be reversed. That means whatever is the situation, it is always going to be directed from the negative charge to the positive charge. So that is an important concept regarding electric dipole moment. Now let us go for the derivation. Now before derivation, let us go for derivation. Let us consider an axial point axial point P. Axial point means this particular point P is located on the line, somewhere on the line joining the two charges in the electric dipole. So this is a arbitrary or experimental point P in the axial position. Now the electric field intensity at this particular point P due to charge plus Q is in this direction, E plus Q. And the electric field intensity at point P due to this particular charge minus Q is in this direction, E minus Q. Now you might be confused why I have written plus Q, minus Q, and the vectors are, the lengths of the vectors are different and their directions are different. Let me just give an explanation. We know that at a particular point, the electric field intensity due to a positive source charge, at a particular point, the electric field intensity due to a source charge, a positive source charge, is always directed away from the source charge. So if this is the source charge, the electric field intensity at this particular point P have to be directed away from it. That means in its opposite direction. So if this is the charge, it has to be directed this way, away from it. And the electric field intensity at a particular point P due to a negative source charge minus Q is always directed towards it. So since minus q is here, so the electric field intensity due to a point P because of this negative charge is in this direction. So E minus q, electric field intensity due to minus q source charge, negative source charge, is in this direction. Now the vector lengths of the vectors are varying. Why? We know E equals to what? K q by r square. K and q are constant, the source charge is constant, K is constant, so E is inversely proportional to r square, right? So less is the distance, more is the electric field intensity at that point. So here for P, plus q charge is situated near it, nearby, so the electric field intensity due to plus q charge, this one, is greater, hence the vector is also greater. But on the other hand, the minus q charge is situated far away from it as compared to plus q charge, and hence the field intensity, the magnitude is lesser, so this vector is less. Understood? Now next, what are we going to derive? The expression, right? Okay, now for this derivation there is an important there is an important unit vector that we are going to introduce, and that is p cap. That is nothing but the unit vector along the direction of electric dipole moment. What I have mentioned already, that electric dipole moment is always directed from the negative charge to the positive charge. So this is being a unit vector, its value is obviously 1, but the direction is in the direction of electric dipole moment. That is, in this particular case, it is rightward directed, because negative charge is here, positive charge is here, so when it moves from negative to positive direction, it has to be rightward directed in this particular case. So p cap is a unit vector along the direction of electric dipole moment. That is, in this particular arrangement, it is rightward directed. Fine enough. This is the electric dipole unit vector p cap. Okay, now let's go for the derivation. So electric field intensity at point P due to plus q charge, the magnitude, okay, only the magnitude, equals to K source charge plus q, only the magnitude, again q. Now distance between them. Okay, now let's say the distance between the center of these dipole and this particular experimental point P is r. Okay, r distance, and as we have already mentioned, these two, as this is twice a, so this is a, this is a, that is already done, but I just forgot to mention you the distance between the center of the dipole and this experimental point at the axial position, and that is r. Consider just our distance, we are just considering it as r. So now the distance between q and this point, because the electric field intensity that we are going to consider here is because of this particular charge, so the distance between them is something that we have to consider here. So the distance between plus q charge and P is what? From the geometry of the figure, if you see, it is r minus a. Yes or no? R minus a, this o plus q, r minus o plus q is going to give us the distance between plus q and P, and that is the distance we need now, right? So it is r minus a, r minus a whole square. Why whole square? Because of this particular thing. Where this particular thing, r whole square, this is small r minus a whole square. Okay. Now substitute the value of k, 1 by 4 pi epsilon naught q, the magnitude of charge, r minus a whole square. Done. Now what we have to do, if we have to arrange this thing vectorically, e plus q. Okay, now this is as I have already discussed, the direction of this particular electric field is rightward. Okay, and the direction of the electric dipole moment, the unit vector along electric dipole moment in this particular arrangement is also rightward. So these two are same directed, and hence we can write here p cap unit vector. First of all, it's a unit vector, so magnitude is 1, doesn't matter, but the direction is something that matters. So the direction is rightward and this direction is also rightward as already discussed. So we are going to plot here p cap. And when we give here a p cap, a unit vector, another vector symbol is going to be inserted here. So the vectorical expression of the electric field intensity at the particular point P due to plus q charge is this. I suppose it is clear. Next up, E minus q equals to 1 by 4 pi. I'm writing this directly in the vectorical form, q distance. Now distance between minus q charge and p, what is it going to be? This is r, this is a. Minus q and p, the distance between minus q and p, of course it is r plus a. This is a and this is r, and the total distance is giving us the distance between minus q and p, so it is r plus a whole square. The direction is minus p cap. Yes or no? See, the values are this r plus a, r minus a, minus p cap, because see this p cap, this particular vector p cap is rightward directed, but the field intensity due to minus q charge is leftward directed. So these are anti-parallel, right? So the direction is towards opposite side of p cap, so it is minus p cap. This is already explained why r plus a whole square, and this is the vectorical form of the electric field intensity at the point P due to the charge minus q. Okay, also done. Now what are we going to do? Simple, the total. We are going to find out the resultant field intensity at this particular point P using principle of superimposition. So E axial equals to E plus Q plus E minus Q plus Q minus Q, which is equal to, just plot in the values. This is say equation 1, this is equation 2, 1 by 4 pi epsilon naught into Q. Okay, the derivation part I'll just solve it and give you in the next video.